All right, hello you guys, Mr. Jones here, and we are just going to work through this review that you guys have for your test. Now keep in mind, I'm going to be doing this without a calculator, but obviously you would have access to your graphing calculator, so I highly recommend using that graphing calculator to look at the graphs and all that, but I'll be doing this without that, okay? So I recommended number one, try to do that with using that strategy where we solve it algebraically and set up your solutions using that number line, okay? So in order to do that, we would need to factor this. We would need to factor x squared minus 9x plus 18, and that would end up factoring into x minus 6, x minus 3 is greater than 0, right? And so that means that if we take each of these groups and set them equal to 0, we would get our two boundary points, right? Because when we solve algebraically, that's what we're getting, our two boundary points that go on our number line. So positive 6, positive 3 would be the two boundary points. So when we have our number line, we've got 0, we've got 3, we've got 6, right? So we're wondering, as we're solving this, we're wondering, okay, which of these sections, right? Because I can have three sections of my number line now, right? I have negative infinity to 3, I have 3 to 6, and I have 6 to infinity. So out of those three sections, I'm wondering which of those sections would be solutions to this inequality. And so again, what I do is I choose three test values, right? So I'm going to test 0 for my first section. For my middle section here, I'm going to test 4. You could also test 5 or whatever. And then above 6, I'm going to test, let's go 8. Okay, so I choose those numbers, right? And what I'm doing is I'm substituting them in. Again, you can substitute them into either the original or the factored version. I'm just going to use the factored version. So 0 minus 6, 0 minus 3. And I get my values there, right? So that would be negative 6 times negative 3, negative 6 times negative 3, positive 18. And so I'm wondering with positive 18, right, my inequality here says greater than 0. So I'm wondering, is 18 greater than 0? Is that a true statement? Yes, it is true. 18 is greater than 0. So what that means is, right, the section where 0 is a solution, or the section where 0 is, that whole section from negative infinity to 3, that would be included in my solution when I write my solution at the end, okay? And then choose another numbers, so 4 minus 6, and then 4 minus 3, right? 4 minus 6 is negative 2. Negative 2 times 4 minus 3 is 1. So negative 2 times 1 would be negative 2, and is negative 2 greater than 0? No, it is not. That is a false statement. So that means that this middle section between 3 and 6, not part of my solution, okay? And then lastly, 8, so 8 minus 6, 8 minus 3, okay? So 8 minus 6 is 2, 8 minus 3 is 5, 2 times 5 is 10. So is 10 greater than 0? Yes, of course, so that is also true. So 6 and above are solutions, okay? So then, how do we write that, right? Writing in interval notation, so we would write that from negative infinity to positive 3 and positive 6 to infinity would be solutions to this inequality, okay? So that's how we'd write that. And again, no brackets here because it is just greater than, not greater than, or equal to. Okay, now I'm going to use the rest of these kind of sketching a graph. Okay, again, I'm not going to show the graphing calculator on here, but again, you guys know how you'd go about that. In the graphing calculator, we've shown that. So we'd have positive 8, right? We have to plus 8 to get it to equal 0. X squared minus 6x plus 8 is less than or equal to 0. And then again, because I'm not using my calculator, I'm going to just factor all these because that's going to help me know where my x-intercepts are. So this tells me that my x-intercepts are going to be at positive 4 and positive 2, okay? So if I sketch the graph, right, this is a quadratic, and so that means the intercepts are going to be at positive 4 and positive 2, so about here and here. So if you looked in a graphing calculator, you'd have something looking like this. All right, and again, with a graph, what we do is we kind of look at this, and it's saying, when is the graph less than 0? When are the y values of this graph less than 0? And again, that would just be kind of looking at my x-axis here. We're wondering, okay, between what x values are my y values below 0? And so that would be just this little portion right here. The rest of it is above that x-axis, only this little portion, right? And so what would I say, right? Those, of course, are my two x-intercepts. So I would say between 2 and 4 using brackets because it's less than or equal to. Okay, so only that little section of 2 from 2 to 4. Those solutions, if I substituted any of those x values in here, would give me a value that is less than or equal to 0. All right, so number 3, x plus 7, x plus 3, x minus 7 is greater than 0. Again, this is a cubic graph, which means it's going to be kind of the overall shape is, I know it's going to be something like this. Okay, so again, I can use that without my calculator. I kind of know that's going to be the general shape. Okay, my three x-intercepts from this, I know they're going to be at -7, -3, and +7. Okay, so again, kind of sketching my graph. We know we're going to have, that's 7, yeah. So -7, -3, and +7. Okay, so my graph is going to, right, just characteristic of every cubic graph, it's going to come up from the left. It's going to curve down through this little point and then come up. Again, I highly recommend typing this into a graphing calculator yourself, but again, for the sake of time, I'm just not doing that. And again, what am I looking at here? I'm wondering, when is this going to be above the x-axis? Okay, when is for what x values are the y values above the x-axis? And again, so I look at this, using my x-axis as my reference line, it is above right here, and it is above for this portion here, from here all the way to the end, right? So I write that, right, from this portion right here between these two x-intercepts, and that would be -7 to -3, so -7 to -3, as well as, right, nothing between -3 and +7, because that whole time it's below the x-axis. But then from +7 and on, it is above the x-axis that whole time. So from 7 to infinity, okay. And again, greater than, not greater than or equal to, so normal parentheses are appropriate there. Sorry, my answer got cut off a little bit. All right, now we are going to be dealing here with rational functions. Rational functions meaning these are going to form mostly those two curves, right, that we've looked at, and we're going to be having to find our vertical and horizontal asymptotes. So when I look at this, okay, so again, the process we went through in class, setting the top and bottom equal to 0. And again, the top equal to 0, that's going to give me my x-intercept. Setting my bottom equal to 0, that's going to give me my vertical asymptote, okay? So if x minus 5 equals 0, x would equal 5, which it means, yeah, my x-intercept is going to be at 5, 0. And then setting the bottom equal to 0, x plus 6 equals 0, so x equals -6. And so that vertical line at x is -6 would be the location of my vertical asymptote. So more of what I'm interested in is going to be here on the left, so I'm going to draw my graph like that. So there's -6 on the x-axis, so there's my vertical asymptote. And then it crosses through the x-axis at +5, so right here. Okay, so then when I go to draw this graph, I know, and again, another piece of information that might be helpful is the horizontal asymptote. Again, not super necessary, but we can still find that. And it would end up being +1, again, using that rule number 2, where we, the leading coefficient, so 1 over 1 is 1. So again, you can sketch that, that doesn't hurt, but so yeah, and I know that my leading coefficients are positive, which means, yeah, this top portion is going to be kind of in the top left, going like that. And again, with this horizontal asymptote being at 1, this is never going to go below the x-axis. And then this bottom portion here is going to come up, cross through the x-axis right there, with, again, that horizontal asymptote there at 1. So again, what am I wondering here? What am I looking for? I'm looking for when is this below the x-axis, right? With my 0 is still my reference line there, right? So when is it below the x-axis, right? So it's really only dealing with one part of my graph, right? Because this curve isn't relevant at all for this answer because it's never below the x-axis. So I really just focus right here on this second half of it to the right of my vertical asymptote. So again, that vertical asymptote location is at -6, right? So that's when it begins, right? At like -6.01 and getting closer to 6, it's going up, up, up. And then right after, so like -5.99, it is now to the right of that and below the x-axis. So I would say from -6 to what? When does it stop becoming, or when does it stop being below the x-axis? And that would be right here at the x-intercept, right? The x-intercept, after that, it goes above for that rest of the time. But at 5, that x-axis, it goes above. So 5 is where it stops being below the x-axis. And again, no brackets, normal parentheses are fine because it's just a less than. All right, same thing. Number 5, so 15 minus 3x over 4x plus 3. Okay, so same process, top and bottom equal to 0. Okay, so I'm going to take these and I am going to solve 15 minus 3x equals 0. Now be careful with this one, right? If you minus 15 from both sides, you could also add 3x. But if you minus 15 from both sides, make sure you bring down that negative. Either way you do it, x ends up being positive 5, and again, that's your x-intercept. Okay, and then the bottom equaling 0, so 4x plus 3 equals 0. That ends up giving you a negative 3/4. Okay, and that would be your vertical asymptote. Okay, so again, sketching your graph. Now, something with this, again, just a characteristic of these rational graphs, you notice that this leading coefficient up top is negative, so it's almost going to be the flipped around version of this, where this half's going to be down here, and this half's going to, so it's going to be a curve up here and a curve down here. Okay, so let me draw my important information first. There's positive 5, my x-intercept, and then negative 3/4, so just between 0 and negative 1 is my vertical asymptote. And again, helpful to see too. So the leading coefficient's negative 3. I know it's out of order, but the leading coefficient's negative 3, and this is 4. So using that second horizontal asymptote rule, I do have a horizontal asymptote at negative 3/4. Again, only helpful to know because we know that this bottom curve will never go above the x-axis, and for this top curve up here like this, it goes below the x-axis, again, where the x-intercept is. So that's kind of what it looks like. Less than or equal to 0, right? So I'm looking below, but I'm also including the points that are on the x-axis as well as solutions. So basically, I'm using brackets. Okay. So again, when is it below? It's below during this portion right here, that whole curve. So I would write that as negative infinity to negative 3/4, my location, my vertical asymptote. And then right to the right of that vertical asymptote, it jumps up here. And it's above, 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 above until my x-intercept of positive 5. So again, I do use a bracket there because that point is right on the x-axis. So 5, comma, and then the rest of this time it's below. So 5, comma, infinity. So no bracket with the negative 3/4 because that is not on the x-axis. Rather, that is a vertical asymptote. So it never actually touches negative 3/4 exactly. So keep it as a parenthesis. All right, guys, good. So let's keep going. So we got this number 6, x plus 6, x minus 3 over x minus 1. So if I set my top equal to 0, x plus 6, well, I want to go quick here. X equals negative 6, x equals positive 3. Those are my two x-intercepts. Again, just kind of flipping the signs of the signs and the numbers there. Or flipping the signs of the numbers in the groups. That's more like it. And then x would equal 1 as my vertical asymptote. Okay. So two x-intercepts here. Okay. If you remember right as well, this would give us a slant asymptote. Again, you don't have to find that, but still helpful to know what to expect if you did look at the graph. So x-intercept at positive 3, x-intercept at negative 6, okay? And it would end up looking something, get rid of that. This first curve would actually become way out, more like this. That's better. And then this would come more like that. Kind of hug, both of those hugging that vertical asymptote. Okay. Yeah, we have this, okay? And again, what we're wondering is when is this? This time it's above or on the x-axis. Okay, so when is it above? From negative infinity, it's below, 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 below. And then again, this x-intercept right here of negative 6, that's when it crosses over and then is above this whole time until it gets to the vertical asymptote. So again, that would be from bracket, because it starts right at a x-intercept that's on the x-axis, so we include that. So from negative 6 to positive 1, where my vertical asymptote is, parenthesis, that's a vertical asymptote, not an x-intercept, so I have parenthesis, And then also, right, so at positive 1, it kind of crosses over and then goes below right here. So from 1 and 2 and then up to 3, it's below, but then at 3, it goes above again. So from bracket 3 to infinity, parenthesis, right? So every time there's a less or equal to under the inequality and it's an x-intercept, you use a bracket for that value. All right, now number 7, lastly. So this one is, again, one of those interesting ones that we're not going to use the x-axis as my reference line. Okay, still the same process, top and bottom equal to 0. Okay, so top and bottom equal to 0. So top equaling 0, that's easy, right? So that's my x-intercept is going to be right at the origin at 0. Bottom equal to 0, x is negative 4 would be my vertical asymptote. Okay, so sketching this graph, we have, again, our negative 4 vertical asymptote. We have our origin, x-intercept. Again, the other important part of this is to include that new reference line because it's not the x-axis that I'm looking at here. I'm wondering when is it going to be, it's greater than or equal to 2, so when is it going to be above or on that x-axis? Okay, so above or on the x-axis. So when I sketch my graph, that's what I'm wondering, okay? And I actually know because I made my key before of this, so negative 8 comma 2 would be my location of that point right there. Okay, which means what? That means that at the x value of negative 8 is when it crosses over and goes above that y equals 2 line. Okay, so this means that for this line, all right, I'm wondering when is it above? So it's only above, the only portion of the curve that it's above would be here, right? From, and I know that's not to scale, right? Negative 8 would be more like over here, but yeah, negative 8 comma 2, right? So basically it's going to be from negative 8 to negative 4, the location of my vertical asymptote. But again, it's points that are on, and again, I shouldn't have put on the x-axis. I should have put on y equals 2. So from negative 8, it's on at negative 8, and then until it gets to a vertical asymptote at negative 4, will it be above? And then after, or to the right of negative 4, it is below for the rest of the time. Okay, so from negative 8 bracket to positive 4 parenthesis. Sorry about the... Okay, now getting into the variation stuff here, guys. So again, pretty easy ones here. Where we're just writing the relationship, nothing extra to do with that. Okay, so S varies directly as M. So you remember that y equals K. X is the default equation for direct variation. But again, with our new letters here, we're going to write, it says S varies directly as M, and the directions tell us to use K as the constant of variation. So we've got, it's going to be S equals K times M as my answer there. Okay. Next one, R varies inversely as Z. Again, the default equation there is K over X, right? Again, with my new variables, R varying inversely as Z. So R would equal K over Z. Okay. Next one, S varies directly as T and inversely as U. So two relationships, right? So S equals, again, don't forget your K, all right? But it varies directly as T, which means it's going to be K times T, and then inversely as U, so U right there, okay? So S equals K times T over U. Lastly, X varies jointly as B and the square of H. Okay, so X varies jointly, don't forget the K, with B, okay? So K times B. Remember, joint variation is that big multiplication chain. That's how our default equation is there, okay? K times B times the square of H. Again, square means our 2 exponent, okay? KBH squared. Okay, good. That's quick ones with variation equations, okay? Now, lastly, we're going to get into some word problems, okay? Again, so this is where we get into our 3-step process of we write the variation equation, we find K, and let me write these. Yes, we write the equation, we find K, and then third step, we solve and answer the question it's asking, okay? So this one, you can read through that on your own, okay? But writing this equation, so again, amount of water varies directly with amount of time. Okay, so I'm going to write that as W equals KT. Okay, K times T. All right, because that direct variation relationship. Okay, So that's my equation. That's step one. Step two, I'm going to use that equation to find K, right? So the first set of values it gives me, a shower lasting 23 minutes. So that would be the amount of time. So that 23 is going to go in for T, 23. And then requiring 4.6 gallons of water. So 4.6 goes in for W, the amount of water. Okay. And then I divide 23, divide 23. So K would end up equaling 0.2. Okay. Very good. So that's my K value, and then I can rewrite that over here. Instead of K times T, I can write 0.2 times T, because I found my K value, my constant of variation. And then lastly, I can solve, right? It says find the amount of water used in a shower lasting 4 minutes. Okay, so again, what is that? That would be time, right? So W equals 0.2 times 4, okay, and 0.2 times 4 would end up being 0.8. And again, always good to put units on here. So 0.8 what? That's an amount of water, right? So 0.8 gallons of water. Okay. All right, so that's that one. Two more, and we're all done. 13, again, you can read through that on your own. Pause the video if you need to. Guys, I messed up on 13 here. I did it as direct variation. I'm going too fast. Inverse variation, right? So again, you can read 13 as you're doing it yourself, okay? But the actual equation of this with inverse variation, right, would be K over R, current over, or K over resistance equals current, okay? So step two, you use that equation, right? So it says in the description that the current, or I, is 240, right? So that's going to be put in for I, 240. And then K over, and the resistance is 3 ohms. Okay, so 3 goes in for R. And then we multiply both sides by 3 to cancel that. So 240 times 3 ends up being 720 is our K value. Okay. So again, we can rewrite our equation. I equals 720 over R. Okay. Then let's answer what it's asking. It's asking us to find the current. So find I when the resistance, or R, is 12 ohms. Okay. So if R is 12, 720 over 12, and I would equal 60, and that unit again they use for current is milliamperes. There you go. Not elephant ears, but milliamperes. Classic. Okay, number 14, last one. Big one here. Pressure of a gas varies jointly as the amount of gas, blah, 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 blah. You can read the rest. Okay, but let's just, so pressure of gas. So pressure is going to be P. Don't forget K. Varies jointly, so multiplication chain. Amount of gas, so let's use G for gas. It's not giving us variables, so we can make our own. Amount of gas and the temperature, okay? So that is our multiplication chain. And, right, so it's these two multiplied, but we have another relationship inversely as the volume. So we have volume at the bottom. Okay. So I'm definitely going to need a calculator for these values, but don't worry. The pressure is 1395 when the number of moles is 7. So moles, again, tie it back. Gas is measured in moles, so we don't know K. Moles is 7. Temperature is 310 Kelvin. Very, very hot. So 310 Kelvin, and the volume is 560. Okay, so the volume is 560. Okay, so again, we solve this for K, right? We can multiply. So up top here, we get 2170 K times 2170 over 560. Okay, and then 1395. Okay, and basically you can multiply by 560 and then divide by the 2170. Huge numbers. You end up getting a nice round number of 360. So again, our third step, rewriting this, P equals 360 times G times T over V. Okay, so there's our equation with our new K value in there. And then just wrapping it up, let's put in all the new values. It asks us to find the pressure, so find P when the number of moles is 6, right? So K is 360, gas is 6, temperature is 290, and the volume is also 360. Okay, so it's nice here. Got 360 on top, 360 on bottom. Very cool. I can just cancel those. So P equals 6 times 290, 1740. So the pressure is 1740. And what's our unit for pressure? It is the kilopascals, of course. Very good. Okay, guys. Okay, so that is it for the review. Hope that was helpful. Thank you for watching.